Hi, please let me know who works on a project where there's some, really old piece of code which everyone's hate to touch. Yeah, this code which already smells, but still works somehow. And if you're gonna touch it, you just break everything. Yeah, so I work on that problem. We used to have this problem in SpringWorks. And today I'm gonna tell you a story about that. So an agenda for today is, first of all, I'm going to explain what is provisioning in our understanding in SpringWorks. So then I'm going to show you our current problem in the old provisioning architecture. And then I'm going to display some kind of high view of our new architecture. And at the end, I'll show how RX help us in the context of the new architecture. So at the SpringWorks, we built kind of huge infrastructure for connected cars, and just to connect one user, we need to pair together 3 different things. The first one is a car, the second one is a hardware, and the third one is the app. So user should provide kind of a lot of information for us, and as we understood, it's not so easy. And I got a story about our old provisioning architecture. So what is provisioning for us? We call provisioning every flow where a user needs to populate some data or fill the form or go through the wizard, something like that. It might be a registration flow, change vehicle, change hardware, etc., etc. And I'm gonna start explain the problem from very easy flow from the registration one. So when user want to register in the app, he basically just open the app, press a button, and goes to the check vehicle screen, where we need to verify is it compatible vehicle or not. So when we've done that, we store this vehicle on the device because we couldn't store it on the server because there is no any connection between vehicle and user yet until he pair, and and only then we can create a user, and the user needs to provide email address and password, some information. So we create user device, then we can go and show hardware the screen where we also ask for hardware information and store it on the device. So then we have some information step where we show user how to insert hardware in the vehicle and where he can find an OBD port. And only after that we can really pair all this information together. It's user information, vehicle, and hardware. But just imagine if user fails somewhere in the flow, like in a hardware ID. For example, he just downloaded an app and he doesn't really have any hardware. So he called the support and asked where can I get it and how to buy. So he returns maybe day or week or months, wherever later. And we need to return user to exactly the same step. And first of all, user need to enter vehicle information because we still don't have it. And when user enter the vehicle information, that's everything became very tricky. Because in the old provisioning architecture, in this view controller, we made a decision where should you go next based on data that we have. And this is kind of broken because we had this decision making in each screen in our flow. And when user passes check vehicle, go to check hardware because he already have a user, and then he goes to pair screen, and now imagine fail again. For some reason he couldn't, or he forgot to enter hardware in the car, or something like that. So then we need to return user back to the pairing screen, and we are making decision right there at the top where we in some redirector for registration, something like that. One of the first problem was we tried to make decision not in a single place, but everywhere in the app where we just can't do that. And now let's make it even more complicated. We was a smart guy and we decided, we should reuse this screen all our other flows, when user want to change vehicle. But we also did it in some wrong way, and instead make some smart configuration, use modern architecture pattern like MVVM maybe. we decided, okay, let's just hard code this business view controller and check if user going to change vehicle screen and has this information that we should go, for example, in a pair screen or something like that. And now imagine we had about 10 different flows which we tried to have in like 6 view controllers. And this logic was so huge and complicated that anyone wanted to work with that at all. And once I, with my colleague, we like spent maybe 3 or 4 hours just trying to build a diagram and picture how flow looks like, just to understand. And it looks like that. Yeah, even here you can see a lot of arrows which going from different directions to the same screens, and different arrows which go from one screen to like 3 different one with different kind of data. And it was a big problem. So start from that, we decided, yeah, we should just remove everything and start the new architecture. So based on this knowledge, we tried to define the problems in our old architecture. So the first problem was unclear and complicated screens. It's definitely true. The second problem was not obvious sequence of screens, because we didn't have a single place where you can just open and look and understand what sequence do you have for registration and what sequence do you have for change vehicle. So we didn't have that place, and it was kind of... so the third problem was each screen provider tried to process few different flows, and also fuck up on somewhere here. Yeah, it wasn't testable at all. And when our testers tried to test all these flows, they actually had around like different accounts in 10 different states, and they just sign up in all this account and try to go there. It was super crazy, and they spent like the whole day just testing registration. It sounds stupid. So the second problem is modifications could inadvertently affect flows. We faced this problem a few times when we just like changed design for registration, and then we realized, oh, we broke like top up. Why? How does it work? So yeah, and it wasn't reusable at all, and we didn't have even a chance to reuse somewhere else. And one of special things in our project that we have for different registration flow for different countries. For example, in Sweden, you need to provide registration number, hardware, and user information. And in Switzerland, you don't need to provide registration number because he already knows about that. So you need to do like hardware ID, and that's it. And we want to configure all these flows in a different way for different countries. So, and we wanted to reuse it, but we couldn't. So what did we do next? We tried to group all this and make some requirements for our new architecture. And the first requirement was a clear and configurable sequence. So we wanted to have like a single place which you can just open and look at the steps which you have for this special flow. So the second is a single responsibility and independence. So each view controller should be single responsible and should do only one thing. It shouldn't care about any other flows, any other view controllers and stuff like that. So, and it should be independent from the flows. And of course, testability and allow to pass predefined data, because we want to make it a bit more simpler for our testers to reproduce different steps and states. So let's have a look at our new provision architecture. Oh, strange. Different sound when I stay here and there. All right. So first of all, it's clear and configurable sequence. As I say, we wanted to have like a different flow which not related to each other, and they define it like in some place. And the idea was like, for example, for registration, you want to have check vehicle, create user, check device, OID lookup, pair, and pay. So like 6 steps. For another country, you want to have 4 different steps, and the same for another flow. So that was a main idea. what about single responsibility and independence? So the idea was screen shouldn't know anything about other screens, which is reasonable. So then we thought, yeah, screen shouldn't know anything about flow as well, right? And actually we understand, yeah, screen shouldn't know anything. It could be like just a thin black box in a vacuum. Then we ended up right here. So screen should provide some data or an error. So it should have like some input, black box, and output. And then said, oh yeah, it cannot be screen at all. It can be like some asynchronous data provider. Why do we want to work with screens? So, for example, you want to have like a user fetch task where we just fetch some information from the server and return the user. Like, why not? Why it should be screen? And that's how we imagine that. So that's some like abstract space and our data provider. And it also really has to understand flow in a different way. When we have these independent asynchronous data providers, which return some kind of value, for example, A, B, and C, and you expect to receive ABC in the result, it doesn't matter which order you will call the screens. You can just swap them, and it's still ABC at the end. And the same for testability. Right now, it's not related to any flow. Not related to any state at all, and like it doesn't care about any other screens, so we can just test it. And the same for flow. We can mock all of the steps, and it's still gonna work. We can reproduce any result. We can show an error after some screen and check how does it react. So and now the most interesting part. I'm gonna tell how did we use RIGs in the context of this new. So as you remember, we have this high picture of our definition of a flow. And as we decided, each screen is a synchronous data provider. So a synchronous data provider we could assume as some return a callback with a typed result. And we can do that for all functions, right? And then we need to combine them together. Something wrong with animation. Okay, and we can do that in a normal imperative way, let's call it like that. And to be able to do that, you need to screen after another one. Like in a callback of first screen, you need to call second one. In a callback of second screen, you need to call third one. But when you have like 10, 15 screens, it's gonna be a callback hell. Not so nice and a bit hard to work with that. So what have we done? Realize that in the RX you have a flat map function, which just allows you to combine observables to return one observable from the result of first observable. So, for example, when we receive result of first screen, we return observable, which is second screen. When we receive result, we return observable on third screen. So that's how it looks on the app right now. It just observable which create from initial data, and then we have a bunch of flat map functions which represent screens. And one of our case, when you want to change order of the screens, you can just swap this function. It is very clear, it is in one place, and like it just defined right there, and it works. So what about single responsibility and independence in the reactive programming? I probably spoil it a bit, showing observable to you, but this asynchronous data provider, it's actually an observable. So we created a protocol which we call flow observable task. We just return observable of defined type. So as you could guess, right now we can wrap everything what you want inside this observable. So it can be like to the server. It can be some fetch image from the server, from the internet. It can be view controller as well. So that's actually what we did. We have flow observable view controller task, and we kind of just wrap view controller. We create view controller and present it, and we provide subscriber. So when you want to return controller, return it to subscriber, and it's returned to the servable. And next screen started. So that's pretty simple, like just only 5 lines of code. And it is really testable thing as well, because right now we don't need to mock view controller to mock some huge thing. We just mock an observable, which is like mockable like that in one line. And if you want to return an error, you return an error. If you return just, you return something one. You can like return 10 different values in the interval or wherever. So, and conclusion of all of that, I could say we spent about like 2 weeks to implement this new architecture. And now it takes only 2 days to realize a completely new flow. So modification no more than like half an hour. And I could say it's 10 times more productive and effective for us to work with a new architecture than with the old one. And I think that's a great result. And our products managers, they also benefit of investment in the architecture changes. And I'm pretty sure that next year we're gonna invest much more in the architecture, and that's what I wish to you. Thank you.
I think that's a great wish for Santa, maybe. So do you have any questions?
Regarding the flows, how often, for instance, if you enter a new market, a new language, a new country, you have to like come up with a completely new set of flows, or do you reuse or implement new flows when needed?
So right now, when we go into the new market, we need to implement around, usually it starts from 4 different flows, because it's the registration, change hardware. So right now we are totally reusing old screens, but with the different configurations. So we are going a bit more deep into configurable view controllers. Right now we provide view models, which could be like one view, one field, but a different behavior for different markets. So or different content, like copies and images. And I could say we reuse almost everything right now, and the only thing that we really do is like configure this flow with flat maps.
Different hardware, like different car models, trigger like different paths in the flow as well?
No, the hardware is a device that you enter in a car, and the OBD port is like a generic one. So we have a different one hardware. We use IMEI for another one. We use a serial number, which is like less digits. And we also handle that in view models for our view controllers. So it works.
Thanks.
Any more questions?
Thank you. So if this were not possible for you to use RX architecture, what would be second best?
Second best, I don't know. I think you can do that using a plane like MVVM, and it's gonna work. It will be a bit more dirty, or like just a bit more code. Yeah.
Yeah. The final, like, ever any drawbacks using RX in production, like?
We didn't find anyone.
So you have no problem with like disposing and stuff like that?
Maybe not obvious disposing cycle. So we had a few bugs, but like we fixed them when. So we expected that the controller will be disposed, will be deinitialized, and data will be disposed. And we had like a timer which tried to fetch data from the server, but when we switched up, the controller didn't dispose and like still fetch data. Yeah, I think it's kind of a problem not using RX. So yeah, I still do.
All right, great. Well then, thank you very much, Vlad.
Thank you.